Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Abdullah Fadi Hisham, and now I'm going to present for assignment 2 case study for subject SKEE 4113 Moderate Control Theory. So first, the group members, it's me, Abdullah Fadi Hisham, Ahmed Islam Al-Sayyid, and Isa Muhammad, or Nick Omar bin Nick Muhammad. First, introduction of the control system. Any control system we develop or create by others need to be controlled so we can see what is the ongoing process and what is the initial result or what is the problem that we face, the system, and many more. So in order to check the system can be controlled and observed, we need to do some tests on it with some with both manual calculation and programmed system to tell us if the system is able to be controlled and observed. Some of the systems we have is difficult and complicated, and it's hard to control it manually. So that's why we be using modern control system. We will be able to control these systems easily. Introduction on the state variable. Feedback control system is a type of control system that tends to preserve a specified link between one system variable and utilizing the function of these variables to compare one to another. The difference as advice for control, the cornerstones for control has been the feedback idea, system design and analysis, implementation of the feedback give us the ability to manage desired result and can it call for consideration of the problem of the stability of response. The problem statement, as shown as in the figure, heat exchanger process whose purpose is to maintain the temperature of a liquid at a prescribed temperature, as the temperature is measured using sensor of a transmitter that sends the measurement to a corresponding controller that compares the actual temperature with desired temperature set point. The controller automatically opens or closes a valve to allow or prevent the flow of the steam. To change the temperature in the tank, the corresponding block diagram for the system is shown in figure 1b. So this is the problem statement figure. This is the system itself and the transfer function over here. So the objectives. The objective is to check the transfer function system is controllable both manually and by using program. Second, to check that if the transfer function system is observable both manually and by using the program. Controllability. First, convert the transfer into a state space equation as shown here. And then the state space equation itself is in here. So then draw the flow graph of the system, and then we check the controllability to determine if the equation above is -1. Thus, the system is controllable. This is for manual calculation. Now we check the verifying controllability using MCSAP. Insert the values of the state space, desired overshoot, setting time, and third pole value to the system. Then click controllability. And then system output controllability matrix approve that the system is controllable. Note, both controllability matrix and its determinant is identical to the calculated one. Controller design, state space representation in phase variable, and then calculate the SI minus A minus PK, and then calculate the controller design, determine the sigma and omega n, and then after that we resubstitute and compare, and then find the transfer function, and then verify controller design using MCSAP. Insert the values of the state space desired, overshoot, and then setting time, third pole to the system. And then we can see the result state space equation and state variable feedback gain. And note, the system output is identical to the calculated values. So verifying the controller using design using MCSAP, system response after controller design. So this is the graph. And then if equivalent transfer functions, and then the observability manual. Now, after finishing with controllability, we check for observability. So this is the manual calculation first, the desired design, and then the omega n, the verified the observer. So after that, the is not equal to 0, so then the system is observable. So after we get these values, now we can verify the observability via MCSAP, the program. After we check the program, the system is observable. And this is the graph of the system. And then in conclusion, after checking both controllability and observability transfer function, both manually and using program, we will be able to identify that this transfer function can be controlled and observed without any problems. So we checked the manual calculation and the programmed calculation. We got them both the same, and then both they showed that the system is controlled, can be controlled and can be observed. Then the system is easy to be used and observed and controlled in the future. So this was the presentation for this subject. My name is Abdullah Fadi Hisham. Thank you for listening.